Hi everybody, hi. Hey, hi everybody, hi. Stop the music! There, that's better. Hi everybody, hi, Mike here. Today we're going to talk about redox reactions again, balancing them. Hey, when you look at this reduction potential chart, you see there's a whole bunch of stuff that ain't just the thing being oxidized and reduced. That complicates matters. So we've already done neutral solution. We've already busted things into half reactions and learned the value of balancing electrons on each side. So we're going to kick it up with acidic solution. So what happens when the electrolyte requires or is an acid? There's a whole bunch of steps. They look intimidating, but if you just follow them one at a time, it's not that bad. So I'm going to pick out an example. We're going to follow all the steps, and we'll do one that's acidic solution and then one that's basic. Now, why are we doing this? Well, that's because in a real battery, sometimes it needs to have acid, such as your automobile battery, that is acid electrolyte in there. Sometimes with those like consumer, what would you call them? Your AAA, AA, your C's, your D's, those are alkaline batteries. So acid and base play a key role, but we've got to sort of follow rules because we want to minimize our variables. All right, so let's pick this one. I picked this out of just a standard textbook, and we're going to take that reaction and we're going to balance it in acidic solution. So the very first step is we're going to take these things and break them into half reactions. So I'm going to take our manganese and I'm going to split it up. MnO4 goes to make Mn2+. I'll leave the subscripts off. We'll put them in at the end. All right. I'm going to take tin 2+. Goes to make tin 4+. So that's the first step, is to break them into half reactions. Now, you don't have to completely understand the next steps, but just trust me, we're trying to minimize our variables, okay? The next step is we are going to balance oxygen. No, I'm sorry. I skipped a step, folks. We're going to balance everything that isn't an H or an O. We're going to balance everything that isn't hydrogen or oxygen. Well, you know what? That's manganese here, and that's balanced already. One manganese on each side. Tin here, one tin on each side. So that's already, that step is already taken care of itself. All right. So let's go and go to the next step, which is to balance oxygen with water molecules. All right. Balance oxygen with water molecules. So okay, top reaction. I got 4 water molecules on the left. And excuse me, I got 4 oxygens on the left, and so Freudian slip, I need to put 4 waters on the right. And yes, that's going to jack up the hydrogen. We'll take care of hydrogen in the next step. Down here with the 2 tins, tin 2+ going to make tin 4, there is no oxygen, so we can just skip that step. All right. Now, we just messed up our hydrogen on the top one, so the next thing is we're going to balance hydrogen with H+ ions. So I'm going to go and look at this, and I'm going to say, well, I got no hydrogens on the left, and I got 8 hydrogens on the right, so I'm going to put H+, and that's because this is an acidic solution. The next part is probably the hardest for most of you, all right? We're going to balance charge with electrons. So I'm going to take and I'm going to look at the charge. Now, if you have to, it's okay to get confused when the charge is in multiple places. And sometimes what you might want to do is just sort of write a little cheat note here. But you got 8 H pluses and MnO4 minus. So remember, that 8 multiplies through. So that is a charge on the left of +7. You can do that to keep yourself straight. And then it's easy to see that on the right, that's a charge of 2+. So you got +7 on the left, +2 on the right. What we need is we need 5 electrons. on the left. All right? And now, yeah, on the bottom one is a little bit easier to see. You got a +2 and a +4. And to make each side, doesn't have to be 0, it's just got to be the same charge. We got 2 electrons. Now, a couple things. If you're doing this and you get the electrons to be on the same side, you did what we call in science, jacked it up. All right? So go back and look what you did, because your electrons should always be on the opposite sides. All right? And then what we got to do is we've got to, because by the way, there is no such thing as 2 oxidations or 2 reductions. Make sure the electrons cancel. Okay, that doesn't mean I can just write 5 electrons on the bottom one. What I can do though, let me get rid of that so it doesn't confuse me. I'm going to go and I'm going to multiply this whole reaction by 2. And I write this, multiply this whole reaction by 5. And now this is where I know myself to know that I've just got to go ahead, one step, write it all over again, add them together, and then there's a way you can check yourself before you wreck yourself. So what I'm going to do is I'm going to write this whole reaction again after I multiply it by 2, the top one. I'm going to write this whole reaction again after I multiply it by 5, the top one, and our electrons should cancel. There we go. Now what needs to happen every time you do one of these, see how there's 10 electrons on the left and the right? They need to cancel. Otherwise, the universe is going to fill up or empty itself of electrons, and that is not going to be pretty. So now what we're going to do is we're going to go ahead, having the electrons canceled and on opposite sides, of course. We're going to rewrite this bad boy with all our subscripts and make it look nice and snazzy. 16H+. And by the way, then what we should do to be prudent, we should check ourselves before we wreck ourselves, but that comes at the end. MnO4 aqueous. I might have to use +5SN2 plus aqueous. Goes to make, looks really long, and that's impressive. You know, do this at a coffee shop. It looks really impressive for everybody watching. And if you really want to look impressive, you write this out on glass like they do on TV. But now, I've not done this particular problem in a long time, or maybe ever. So I'm gonna check myself in case I goofed. And the one way you can do that, depends on how much time you got. If you don't have much time, check the charge. Chances are if the charge is the same on each side of the arrow, you got it right. Okay, but then you could like pick one element that's everywhere, like oxygen or something. So, okay, let's go ahead, and before we declare this the correct answer, I'm going to go ahead and look at the charge. 16 positive right there, 2 negative, and 10 positive. So 26 minus 2 is 24 plus is the charge. Now, it doesn't have to be 0. There's probably a whole bunch of nitrates that we're not showing. It's the net ionic. Imagine how complicated it would be then. So 24 plus and 4 plus and 20 plus, the charge is correct. All right, just pick any elements now and you can see if it's balanced. 2 manganese on each side, 5 tins on each side, 8 oxygens on each side. Folks, I'm going to declare victory. That is the balanced reaction in acidic solution. All right, it's not that bad. Just do a few reps and you'll feel comfortable with it after a while. Next, we're going to do an example of basic solution. There's only one step at the end. Everything else is the same. So let's do another example where the electrolyte has a base in it. Okay, in my obscure collection of textbooks, I pulled this one out from my 26-year career of having all sorts of textbooks in piles. So I found this one, and I've never seen it before in my life, but I think we can handle it. This is going to be split it into half reactions, okay? So the first step, we're going to split this bad boy into half reactions. So ClO minus goes to make Cl minus. And then CrOH 4 minus goes to make CrO4 2 minus. I'll leave the subscripts off for now. All right. Okay, first step. Well, we got off easy on this one too. The first step is to balance anything that ain't an H or an O. So that would be the chromiums and the chlorines, and they're balanced. There's one on each side. So the next step is to balance oxygen with water molecules. So I'm going to go ahead up here and I'm going to put a water molecule there. All right. Over here, down here, I got nothing. I don't have to do anything because there's 4 oxygens on the left and 4 oxygens on the right. Okay? Next step, balance H with H plus ions. So I've got no H pluses and no H's, excuse me, and 2 H's. So I'm going to put 2H plus. Now we're going to take care of those H pluses later because this is not an acidic solution. It's going to be basic. So we'll take care of that right at the end. 4 H's on the left, so I got to add 4H plus. Okay, the harder part is to go and look at the charge. This one's gonna be a bummer, you know. This is look at, like, when you got charges all over the place, it's kind of tough. So I just go really slow. Okay, this is +2, and that's -1, and that's -1. Now you look at it, those -1s are, you know, sort of nullify each other. And so what I need to do is I've got a charge of, and if you like to add them up, this is what's dangerous when it crosses 0. So this would be a charge of +1 on the left and -1 on the right. To nullify that difference in charge, I need to have 2 electrons on the left. Now, it's okay to screw up. Just catch yourself screwing up and unscrew it up, all right? So I'm not screwing up here yet that I know, all right? But there better be some electrons on the right or else something's really, really, really wrong. So this is a charge of -1 on the left, -2, and +4. So that is -1 on the left, +2 on the right, all right? So -1 and +2, I need 3 electrons. Okay, and now what we're going to do is we're going to go ahead, we're going to multiply this whole reaction by 3 so that the electrons cancel, and we're going to write this multiply this whole reaction by 2, and then I'm going to write them over again because I don't trust myself. I got to limit my steps and go in order, so I'm going to go ahead and rewrite these right now. There we go. And so just according to plan, the 6 electrons will cancel. You know what else is going to cancel? These 6 H pluses will be canceled by 6 H pluses over there. All right? Now go ahead with me and let's add these together. And when we do, we're going to have H pluses left over, and that can't happen in basic solution, and we'll get to the last step. There we go. And now what's different with basic solution is the last step. We're going to take those H pluses, and remember, it's kind of like algebra. Whatever you do to each side of the arrow, one side of the arrow, you got to do it to the other. So to get rid of those H pluses, which can exist in an alkaline solution, we're going to add an equivalent number of OH minuses to each side, and that's going to form water molecules on the side with the H pluses. Whoopsie, 2 OH minus. So I'm going to make a little, it's going to end up making 2 waters. And those 2 waters will add to those 3 waters. But I can't do that without doing it to both sides. So now what I'm going to do is I've gotten rid of my H pluses, and these 2 waters are going to add to those 3 waters, and we're going to rewrite this whole bad boy all over again, and the net result will be that there will be OH minuses. So let's go ahead and rewrite this. So it'll be, and I'm going to be nice and neat and do it with subscripts and everything, ClO aqueous, right, plus 2CrOH 4 minus aqueous plus 2OH minus aqueous goes to make 3Cl minus aqueous plus 2CrO42 minus aqueous plus, don't forget the waters, and we would have caught ourselves if we'd have not done that, H2O liquid. Okay, so now what we're going to do is we're going to go and check ourselves before we wreck ourselves, and we could go ahead and pick the charge. Let's do charge anyhow. -3 on the left. Okay, so let's count on the left. -3 times 2 times -1 minus, so that's -5. 2 times -1 -7. -7 charge on the left. Better be the same on the right. So this is 3 times -1 is -3. 2 times -2 is -4. -3 plus -7 on the right. So chances are we got this thing right, guys. Now let's just pick like the most complex element that's in every single place except one, which would be oxygen. So I got 3 oxygens there, all right? From that, I've got 2 times 4 is 8 oxygens, so 3, I got 11 oxygens, 2 oxygens there, 13 oxygens on the left. Now we better have 13 oxygens on the right, and hopefully we do, yeah. 2 times 4 is 8 oxygens, plus 5 is 13 oxygens, and so this is able to be blessed as the correct answer. All right. Looks really intimidating on the surface, but it's really just following the steps, slowing down, checking yourself at the end. Guys, you understand every redox equation that could be presented to you now. So go practice more, find some more to practice on, and take care of yourselves. And cue music. Yeah, I was a little hard on the music. It's cool. Kind of corny, but I'll take it. Okay. Bye.